All right, class, I hope you're sitting down because I have some important stuff to tell you here. We're going to talk about the fundamental theorem of calculus. I think you're finally ready. So here's what the fundamental theorem of calculus says. Oops. I'm so nervous I accidentally moved the page. If f is continuous on a closed interval a to b, and capital F is, I won't say the antiderivative, I'll say an antiderivative, doesn't matter which one. F is an antiderivative of little f. Then I can evaluate the definite integral from a to b of f of x dx by looking at capital F of b minus capital F of a. So essentially this says if I want to evaluate a definite integral, there's really two steps. First, I need to find the antiderivative or indefinite integral, which we'll call capital F of x. So find that antiderivative first. Once you have that, look at capital F of b minus capital F of a. We're just plugging in our upper and our lower limits of integration and then subtracting the two. That's all there is. So let's look at our example. Remember, in the last section we said, hey, we wanted to evaluate or approximate the area under 9 minus x squared. So that's the function I'm going to integrate first. I'm going to integrate 9 minus x squared on the interval 0 to 3. So first step, I need to find my antiderivative. So I need to find the indefinite integral of this function first. So just using my power rule, that would be 9x minus x cubed over 3. Then I'm going to draw in a little shorthand here. This line here at the end, 3 and 0, this says, hey, I'm going to take this function that I just found right here, 9x minus x cubed over 3. I'm going to plug in 3, I'm going to plug in 0, and then I'm going to subtract the 2. So, okay, that's my first step. I found my antiderivative. Second step now, let's plug in our limits of integration. So first, 9 times 3 minus 3 to the third over 3 minus 9 times 0 minus 0 to the third over 3. So here we just have a little bit of number crunching to do here. 9 times 3, this gives me 27 minus here 3 cubed would be 27 divided by 3, that would be 9. Minus over here, 9 times 0 is 0, minus 0 to the third is 0, over 3 is 0. So I end up with 27 minus 9 is 18, minus 0 gives me 18. So the area bounded by my function, 9 minus x squared, and the x-axis is actually equal to 18 square units. Let's check our answer with our approximation. We said in the last example, we approximated the area to be 22 units squared, and we said that was an overestimate. So we said 22, that's too high. We went and we found the actual area under the curve, 18. Yep, that is absolutely less than 22. So this is really, really cool. It gives us this relatively straightforward way to find area under the curve. As long as we can integrate this function, which that's going to be the hardest part, is can we integrate this function? As long as we can integrate that function, we can find the area under these curves, which is really cool. So let's look at some more examples. We're just going to look at a bunch here. So next I have, and actually let me just rewrite this because this is kind of messy already. We want the definite integral from 0 to 6. I have 2x minus 1 dx. So okay, my first step, I need to find the antiderivative of this function. So here, this is just a power rule. I should have x squared over 2, or just x squared, minus the antiderivative of 1, that's going to be x, And then I'm going to evaluate this at 6 and at 0. So all right, what do we have here? We have 6 squared minus 6 minus 0 squared minus 0. If you want to, you could figure out this part first and then this part separate and then subtract the two. The order that you subtract them is important, but if you want to break this whole thing up into kind of 2 or 3 steps just to make it easier to manage, then absolutely you can do that. But here I got 6 squared. This is 36 minus 6. Minus over here 0 minus 0. So that's just 0. 36 minus 6 gives me 30 is the value of my definite integral. This is so cool. I am so jazzed. All right. Let's look at more. Here I have the definite integral from 1 to 3. I have 4x minus 2e to the x plus 5 over x dx. So again, I want to first of all find my indefinite integral. I want to find the antiderivative first. So antiderivative of 4x, that's just going to be a, let's see, that's a power rule, so that'll be 2x squared. Minus antiderivative of 2e to the x, that should be minus 2e to the x. And then plus 5 over x, remember I can think about that as plus 5 times the integral 1 over x dx if you need to, because I think that makes it easier to see that my integral should be 5 natural log absolute value of x evaluated at 3 and 1. So okay, let's take 3 and 1, we'll plug these in, subtract the 2. So let's see, 2 times 3 squared minus 2e to the third power plus 5 natural log absolute value of 3 minus 2 times 1 squared minus 2e to the first power plus 5 natural log absolute value of 1. And I'm just going to do my best to simplify this as much as I can. So let's see, 3 squared is 9 times 2, I should have 18 here, minus 2e cubed, we'll just leave that as 2e cubed for right now, plus 5 natural log absolute value of 3. Since 3 is already positive, we can go ahead and drop the absolute value. It doesn't really make a difference in this problem. 1 squared is 1 times 2 is 2, minus 2e to the first, so this will just be 2e, plus natural log of 1. If you look at 5 times natural log of 1 is actually equal to 0. So what I really have here is 5 times 0. So this term is going to drop off. And at this point, I guess I'll just do the best that I can here. Let's see if I can distribute this minus sign. So let's see, I should have 18 plus negative 2, I should have 16 minus 2e cubed plus 2e plus 5 natural log 3. And that's it. I mean, if I want an exact answer, that's where I have to stop. You could, of course, type that in and get a decimal approximation, which I think I'll do real quick. 16 minus 2e to the third plus 2e plus 5 natural log of 3. If you look at the decimal approximation here, this is interesting, and I'm glad I stopped to talk about this. This is negative 13.24 if I round to 2 decimal places. So about, roughly, negative 13.24. And you said, hey, Mr. H, I thought you said that the definite integral tells us area under a curve. Why are we ending up with a negative? I thought area couldn't be negative. I'd say that's a super good question. I'm so glad you asked it. Let me see if I have enough room down here to talk about it. I don't. Perfect. Okay. let me erase some stuff here. And actually, yeah, this is good. Let me erase this. We said there was one piece I kind of glossed over, and that was that the definite integral tells us net area under a curve. That word net is actually really important. Because when you look at a definite integral, it's going to tell you area under the curve. So if I were to draw something, let's just say I drew this in. Anything above the x-axis, it counts as positive area. So the definite integral is going to count this as positive area. Anything, however, that falls below the x-axis, so this region right here, the definite integral is going to count this as negative area. So this is going to be a really important idea in some examples that we'll look at towards the end of this section. The definite integral is going to count anything that falls below the x-axis as negative. So just be careful of that. When we see something that ends up as a negative integral, so here we had negative 13.24, that means one of two things is true. It means either that whole function is below the x-axis on, what was our interval, 1 to 3, so maybe our function looks, I don't know, something like this, where the whole area between the function and the x-axis is below the x-axis, so it could be this case. Or you could have an instance where part of your function is above the x-axis, but then there's way more area below the x-axis. So if I look at this, here's a little bit of positive area, but then I have all of this area that's negative. So the negative area is sort of outweighing, the positive area here. For us personally, it doesn't really matter. It's just those are the two cases that I could have. So key takeaways that I want you to have here: it's okay if we end up with a negative solution, if we end up with a negative answer to a definite integral. That just means you have more area under the x-axis. And the thing I really want you to take away here is that the definite integral counts area below the x-axis as negative. It's a really important idea here. So we've got one last example, and then we'll wrap this video up. Here, this time, I have the definite integral from 4 to 25. I have 2 over square root of x dx. So again, the first thing I would like to do is find my antiderivative. This is maybe not the easiest form to work with because I have this square root. So let's rewrite this as the definite integral from 4 to 25. This is 2, let's do this first. 2 over x to the 1/2 power dx. And then I know I'm going to want to bump that x that's in the denominator up to the numerator. So this is 4 to 25. This is 2x to the negative 1/2 dx. So all right, now we can go ahead and find our antiderivative. So let's see, 2x, I'm going to add 1 to my power, so I should have a positive 1 over 2. And rather than divide by my power in this case, I'm going to multiply by the reciprocal, which would be 2 over 1. And then evaluate that at 25 and at 4. Actually, let's just simplify this. This will be 4. So you can leave this as x to the 1/2 if you want to. Or if you know you're going to evaluate this and you know that, hey, that's just a square root, it might be easier to switch it over to a square root. 25 and 4. So I have 4 square root of 25 minus 4 square root of 4. So I have 4 times 5 minus over here 4 times 2. 4 times 5 here I have 8. Oh, nope, I'm thinking about the next one. 20 minus 4 times 2, there's my 8. 20 minus 8 gives me 12. There is my answer. In the next section, we're going to continue looking at definite integrals, but now we're going to think about, okay, how can we add in our one integration method? How can we add an integration by substitution? Is there anything different that we have to do in that case?